Hello students, today we are going to discuss a very important phenomena in calculus which is called continuity. So in plus 1 class we studied the concept of limit, which was something new and innovative, where we found the approximate value of a function at a point where it fails to exist. So which is called limit. It is the nearest value. Now limit of a function is we always find the limit when we say that yes, the function is not defined at that particular point. For example, limit x approaches to 2, x square minus 4 upon x minus 2. We find this limit, we calculate this limit if, as we know that function at 2 is not defined, it is not existing. So we always say limit x approaches to a, f of x is equal to L, and this L is not equal to f of a. Now consider another function, f of x is equal to x square plus 2x. If I say find the value at this function at 2, so this is just substitution of x is equal to 2, and this is also the limit of this function, because there is no use of finding limit when a value is existing at this point. So this is my limit, also this is my value at the point 2. So I can say limit x approaches to 2 of x square plus 2x is equal to nothing but f of 2. If I draw the graph of any function and it is not existing at a point A, so there is a hole in the graph, I say the function is discontinuous. Again we see the function f of x is equal to x plus 3. Again if I put x is equal to 2 here, it is defined, and this is also the limit of this function. So we can say that function is continuous at x is equal to 2. In other words, normally the limit x approaches to a, f of x is equal to L, and that L is not equal to f of a. But when limit of a function at x approaches to a is nothing but the value of the function at a, then we say yes, function is continuous at x is equal to a. Means continuity means simply existence of the value of the function at that particular point. That's it. Now for example, if I say check whether the sign is continuous at 0 or not, what I'll do, I'll put x is equal to 0 and I'll see sign 0 is 0. 0 means properly defined, so it is continuous. It is the limit also in case of sign x, and it is value also. So limit x approaches to a, f of x is equal to f of a. This result is followed, so it is continuous. Now when function is discontinuous, first point, when limit of a function exists and this is not equal to f of a. Now under this question, all the questions of under this heading, all the questions of limit comes, like when a function is not existing at a point, that means f of a is not existing, only then we find the limit. So those questions are obviously discontinuous. Those functions are discontinuous, and this type of discontinuity is called removable discontinuity. Now next is when limit does not exist, and the reason is LHL is not equal to RHL. So then also function is discontinuous, and this is called discontinuity of first kind. Next, discontinuity of second kind. Here either LHL or RHL or both fail to exist, and that is called discontinuity of second kind. Next is very important, algebra of continuity. Suppose f and g are two continuous functions, then first f plus g and f minus g is continuous. Second, f into g is continuous. Third, f over g is continuous, but it is denominator, so we have to be very careful that g is not equal to 0. Obviously on those points f upon g is continuous. Let us elaborate third point with example. Suppose f is x, g is x square minus 4, both are continuous. So f plus minus g and f into g are continuous everywhere. We can have blind faith on, plus some subtraction and multiplication. But when I divide f with g, that means x upon x square minus 4, so anyone can observe that minus 2 and 2, these are the 2 points which are making denominator 0. So obviously it is not defined and it is not continuous at these 2 points. Apart from these 2 points, it is continuous everywhere. So this we have to be very careful about quotient of 2 continuous functions. Then fourth point, if f and g are continuous, then fog and gof are also continuous. Fog and gof means the composite function. When I say fog, it is f of g of x, means function f is applied over g. Let us see how this works. Suppose f is x cube and g is x square minus 4. Now what is fog x? It is f of g of x. To calculate fog, I have to focus first on g value. So is equal to f of x square minus 4. Then to apply the definition of f of x, which is x cube, so it is x square minus 4 whole cube. Again, now to find gof x, it is g of f of x. So here I'll first apply the definition of fx, which is x cube. Then it is g of x cube, means it is x cube square minus 4. I am applying the definition of g, which is x raised to the power 6 minus 4. So this is how we calculate composite function, and if f and g are continuous, then their composite function, that is gof and fog, are continuous. Now next is some important point regarding continuity. We should know that all the polynomial functions are always continuous everywhere. Friends, we are doing real calculus. That means universal set of this calculus is all real numbers. So polynomial functions are continuous over all real numbers. Remember. But you should know what a polynomial function, like x minus 4 upon x minus 5 is not a polynomial function. Then next is sin x, cos x. They are always continuous everywhere. Reason is again, this point should not be mixed with that all trigonometric functions are continuous. I am saying sin x and cos x are always continuous. Only these two. Then mod x, it is also continuous everywhere. But remember, like mod x is continuous, but if I am watching 1 upon mod of x minus 1, so clearly it is not defined at x is equal to 1, so it is discontinuous. X minus 1 mod is continuous, mod of 2x plus 3 is continuous. So we have to be careful that if something is continuous, okay, but denominator should not be 0 and it should be defined. उस चीज़ का हमें ख्याल रखना है. Now next is continuity in the interval. Now continuity in the interval, continuity is always checked in closed interval, and if a function is continuous in closed interval a comma b, then it should be continuous at every point of closed interval a comma b. Now students, here we should be careful that if I am asked to check the continuity of a function in a closed interval and I am checking it on the basis of single point, then I should know that an interval has infinite many points and it will take ages, but I can't calculate check the continuity of a function in the interval, in the closed interval. So what I'm going to do, basically I am checking the continuity of a function in any interval otherwise. I'll see, is there any point which is making the function not defined? For example, at 1 by x, the function 1 by x in interval minus 1 to 1 close interval. If I am asked to check the continuity of this function at this interval, so clearly 0 is the point which is making 1 by x not defined. So I'll say 1 by x is not continuous in closed interval minus 1 to 1. If it is checked, in the closed interval 1 to 2, then I can say 1 by x is continuous at closed interval 1 comma 2, as there is no point which is making this 1 by x not defined. So let us see some questions of NCERT exercise 5.1. First question is, find the continuity of a function at 0 where function is 5x minus 3. Now I am doing this in formal way. Limit x approaches to 0 f 5x minus 3. Obviously I'll directly substitute this, so x is equal to 0, it is minus 3 only. Also, what is f of 0? Again a formality, I have to put it directly 0, so it is minus 3. So limit x approaches to 0, 5x minus 3 is f of 0, so function is continuous. Next question is that I have to discuss the point of discontinuity where the function is two x plus 3 when x is less than equal to 2 and 2x minus 3 when x is greater than 2. Now in this question we have to apply LHL, RHL. So what left hand limit is? Limit x approaches to 2 negative. 2 negative means less than 2, and when I say less than 2, then I am following the upper definition, which is 2x plus 3. So putting 2x plus 3 here, then left hand limit rule says I have to put x as a minus h. A is 2, so I am putting it 2 minus h. Now normally we simplify the expression, that means we take something common if is there by cancelling the common term, but there is no situation here, so I have no option left than the putting h is equal to 0. So I am putting h is equal to 0, so it is 4 plus 3, so 7 is the left hand limit. Now for the right hand limit, I am picking the definition when x is greater than 2, which is 2x minus 3. Here symbol is 2 plus, I am putting x as 2 plus h. Again no simplification needed there, so I am putting h as 0, so it is 4 minus 3, which is 1. So as LHL is not equal to RHL, so limit does not exist, and as limit does not exist, the function is discontinuous. So 2 is the only point of discontinuity. Similarly, again let us check the discontinuity of the function at this point. So let us calculate left hand limit. Limit x approaches to 0 negative, it is x upon mod x. Same formality, put x is equal to a minus h. A is 0, so 0 minus h upon 0 minus h whole mod. Next is numerator minus h, denominator h, due to mod h cancelled, so left hand limit is minus 1. And right hand limit is simply when x is greater than 0, so it is minus 1, so I am doing the formality, putting minus 1, and finally RHL is minus 1. So therefore LHL is equal to RHL. Now next is f of 0, which is again minus 1, as equality is there. So that means LHL is equal to RHL is equal to f of 0. Therefore function is continuous at x is equal to 0, as it is continuous at x is equal to 0, so there is no point of discontinuity, and hence it is continuous everywhere. So that's all for today. Have a nice day. Take care.